Hello everyone, welcome to this video. In this video we shall discuss a question from June 2018 consisting of 3 marks. In this question we have to tell the given polynomial x raised to power 5 minus 5x plus 2, right? Then this polynomial has no real root, has exactly one real root, it has exactly 3 real roots, and or all of the roots of this polynomial are real, right? So to check the number of roots for a given polynomial, we have a result called Descartes' rule of sign. It tells you how many positive and negative roots do we have for the given polynomial, the maximum number of positive and negative roots that we have for a given polynomial, right? So the maximum number of positive roots, they are calculated by checking the signs of f of x. So in our case, the given polynomial is x raised to power 5 minus 5x plus 2. So the sign of this first term is plus, then the sign of the second term is minus, then that of third term is plus. So you see there is a change of sign from plus to minus over here, and there is a change of sign from minus to plus over here. So in total we have two changes in sign. That is why our maximum number of positive roots are 2. So now they are the maximum number of positive roots that this polynomial may have, but the positive roots may either be 0. We just have to subtract it by an even number. Whatever the value of p is, we just have to subtract it by even number. So we say the possible positive roots of f of x, they may either be 2 or 0, right? So now let us look at the number of negative roots. So the number of negative roots are calculated by changing the signs of f of minus x. So in our polynomial we just have to replace x with minus x, right? So our polynomial earlier was x raised to power 5 minus 5x plus 2. When you replace x by minus x, so it would be minus x raised to power 5, so that would be minus x raised to power 5, and here it would be plus 5x and plus 2. Now you see the signs are minus, plus and plus. So we only have one change of sign over here from minus to plus. These are the same signs. Therefore, this q, the number of maximum number of negative roots, is equal to 1. So now they are either equal to 1 or they could be minus 1. But this cannot be the case, because the number of negative roots, they cannot be minus 1, because we are counting. So counting begins by 1, 2, right? So the number of negative roots is surely equal to 1. So this is the thing. Now we are to calculate the number of non-real complex roots. The formula to calculate this is n minus p plus q, where n is the degree of the polynomial, and number of positive, p is the number of positive roots, and q is the number of negative roots. So right, because we have the value of p as either 2 or 0, therefore this number of real roots, they are either 3 or 1. So let us look at our options. So this option is incorrect. F has no real root. This is not correct, and all are real roots. That is also not correct. Now we are stuck with whether it has 1 root or 3 root. So let us verify this thing, right? For that, we just have to go for some other way to check the roots. What we can do, we can check the behavior of this polynomial, right? So this is a polynomial, this is a continuous function. We all know polynomials are continuous, right? So what we can do, we can check where at which points we have the maximum value for this function, we have the minimum value of this function, by checking where it is increasing or decreasing, right? So to check maximum and minimum, we calculate the derivative of this function. This comes out to be 5x raised to power 4 minus 5, this, right? So to calculate maximum or minimum at at which points, we have to equate this derivative equal to 0. That means we got 2 points, x is equal to plus 1 and minus 1. So at this point we would have either the maximum value or the minimum value, right? So now we can check the behavior of this derivative in this region from minus infinity to minus 1, right? What is the behavior of this function? So we'll check it at some random point, say minus 2 in this domain. So at minus 2 our function's value is positive, therefore our function is increasing over there. In the interval minus 1 to 1, we can check it at random points. So we'll check it at 0. At 0 it comes out to be minus 5, negative, so our function is decreasing, right? And at the point 2, that is we are in the domain interval 1 to infinity, right? So here we'll check it at random points, say 2. So at 2 it again comes out to be positive, therefore the function is an increasing function over here. So in this interval we have function as increasing, that means the slope is positive, that means the function is increasing somewhat like this. And in this interval we have the function as decreasing like this and then this. So that means we would have a maximum over here, some at minus 1, not here, at the point minus 1, because these are the only 2 points at which maximum or minimum occurs, right? So when our first derivative changes sign from positive to negative, at that point we'll have the maximum. And when our f dash, the first derivative, changes sign from negative to positive, then we have a minimum, right? So this is the only possible way we could have maximum or minimum. There are only 2 maximum minima for this curve. Therefore, the curve this intersects this x-axis at exactly 3 points. One is this one, one is this one, and one is this one, right? And we do not have any other way. Beyond this point it will go like this upward, and beyond this point it will go like this, right? However, by doing so we do not know what are the roots exactly, okay? But we know how many roots do we have, right? So the correct option for this is option C. I hope I make this understandable. Thanks for watching.